Okay, so our second lesson for chapter 5 is on dividing monomials. And we are going to simplify quotients of monomials, and we're going to find the greatest common factor of several different monomials. Okay, so the greatest common factor, GCF, which is what we talked about in our last lesson, of two or more monomials is the common factor with the greatest coefficient and the greatest degree in each variable. Okay, so here's what we're looking for. We talked about greatest common factor for integers. So the coefficient is usually an integer. So we're looking for the greatest common factor of the coefficients and then the greatest degree in each variable. Okay, so let's look at a couple of properties and rules here first. So first we have the property of quotients. So if we have A, B, C, and D and they're real numbers, and B and D are not zero because you can't have a zero in the denominator, then A times C over B times D is equal to A over C times C over D. And basically all this is telling us is that if I have a number, I can break it down into, I think this is supposed to be a B here. I can break it down into factors. So for example, if I have 16 over 24, I can say, well, that's the same as 2 times 8 over 3 times 8. Okay, that's all this is telling me. I'm allowed to do that. And then I can say, well, I know 8 divided by 8 is 1, so I can simplify this. So the property of quotients is basically breaking the numbers apart into factors so that you can simplify it usually. Okay. Next, we have the rule for simplifying fractions. If B, C, and D are real numbers with B not equal to 0 and D not equal to 0 because they're denominators, then BC over BD is equal to C over D. And it's basically what I did up here. They both have a common factor, so I'm able to cross that out and I'm left with C over D. For example, if I have 4 times 7 over 5 times 7, which would be 28 over 35, I can cross out these 7s because I know 7 divided by 7 is 1. Remember, this represents a quotient, a division problem, and I'm left with 4/5. Okay. Then we have the rule of exponents for division, which says if A is a non-zero number, okay, so A has to be some sort of non-zero, it can be positive or negative, and M and N are positive integers, then this is how this works. So notice I have a fraction. The bases are the same, the exponents are different. If M is greater than N, so in other words, if M is the larger number, suppose I have x to the 7th over x to the 6th, then this says what we're going to do is we're going to subtract 7 minus 6, which is 1. Think about that. If I have 7 x's in the top and 6 x's in the bottom, I can cross out 6 of them, and then I'm going to be left with just 1 x in the top. Okay, so here's an example now where it says, well, what if n is greater? So if n is the bigger number, let's look at this. Suppose I have x over x to the 6th power over x, and I'm going to do to the 8th power. Again, if I follow the rule and just subtract, it's going to be x to the -2. Well, I can't have a negative exponent. 6 minus 8 is -2. And if you remember the rule, it says flip it over, take the reciprocal, and you can make your exponent positive, which is what this is. It's saying flip it over and then subtract. But by making this number first, so it'd be 8 minus 6, and I flip it over. I like to think of it more of get your exponent first. If it's negative, then flip it over, make it positive, rather than going straight from here to here. Okay, and then it says if they're equal, then it's equal to 1. So in other words, if I have x squared over x squared, well, that's just equal to 1. Okay, so that's the rule of exponents for division. Okay, this one's simple, this one's simple. This one, go ahead and subtract. If you once you get a negative exponent, flip it over. And think of it this way. You have 6 x's in the top and you have 8 in the bottom. If you cross out the 6 they have in common, you're left with 2 in the bottom. Okay, so think about it that way. All right, so let's look at our first example. It says find the greatest common factor of 72x cubed y z cubed and 120x squared z to the 5th. Okay, so first we find the find the greatest common factor, bleh, greatest common factor of the coefficients. This is the hardest part, finding the GCF of these two numbers. So let's start with 72, and I'm just going to write its prime factorization. So it's going to be 2, and again, use your calculator. So 72 divided by 2 is 36, which I can divide by 2 again, which gives me 18, which I can divide by 2 again, which gives me 9, so 3 and 3. So 2 times 2 is 4. 4 times 2 is 8, 8 times 3 is 24, 24 times 3 is 72. So there's a prime factorization of 72. Here I have 120, so 120 divided by 2 is 60, 60 divided by 2 is 30, 30 divided by 2 is 15, which is 3 times 5. Let me go back and double check. 2 times 2 is 4. Actually, I'm going to go this way. 3 times 5 is 15, times 2 is 30, times 2 is 60, times 2 is 120. Okay, so this is what they have in common. They each have 1, 2, 3, 1, 2, 3, 3 twos. And they each have 1, 3 in common. So the greatest common factor is 2 times 2 is 4, times 2 is 8, times 3 is 24. So the greatest common factor is 24. Now, there's other ways to do it, okay? And you might look at it and say, I can do a better way. That's fine. So what they have in common is 24. So that was the hard part. Okay, the easy part is the exponents. I mean, is the variables, because all you have to do is look at the exponents. So how many x's do they have in common? Just look to see, first of all, do they both have x's? Yes. Choose the smaller exponent. This one has 3, this one has 2, so they both have 2 exponents, 2 x's in common. Look at the y's. I have a y here. There is no y here, so they don't have any y's in common. And if I look at the z's, I have 3 here, 5 here. The smallest exponent is 3, so they have 3 in common. All right, so let's flip it over. It says find the product of the coefficients and the smaller power of each variable that is a factor of monomials. So in other words, what we said is we said that our GCF was 24. Make sure you can see this. We have 24. We said that we had, let's see if I can flip this up. We have 2 x's. We don't have any y's. And we have 3 z's. Okay, so that's what they have in common. If we multiply it all together, it's just 24x squared z cubed. Okay, so that is the greatest common factor of these two. The hard part is finding the greatest common factor of the number. For the variables, all you do is look for the variables they have in common and choose the smallest exponent. All right, so we're going to simplify this. And the reason why we want to do this is so we can simplify. So watch what happens here. First, I'm going to find the greatest common factor. So the greatest common factor of 35 and 56. Well, 35 is 5 times 7, and 56 is, I know it's 7 times 8. 8 is 2 cubed. Okay, so the greatest common factor they have then is 7. So I'm going to write 7 and 7. They have 2 x's in common. They have 1 y in common. And they have 1 z in common. Okay, so there's their greatest common factor. So now I'm going to say, well, what do I have left? If I factor this out of this, what's left? Well, I have a 5 and 1x and 5 z's. And if I factor that out, the same thing out of here, I'm left with 8, because 8 times 7 is 56, 3 x's, no y, and no z. So if I say, okay, here's the common factor, and I'm going to cross that out. Here's what I'm left with. 5x z to the 5th over 8x cubed. Now, I could have also done it this way, because sometimes you don't have to go through the whole thing. X to the 5th y to the z. So I could have said, well, I know I can factor 7 out of both of these, and that'll give me 5 over 8. 5 is prime, so that's done. I can cancel all these out, and I'm left with 2 here. I can cancel those out, and cancel this out, and I'm left with 5 there. It gets kind of messy, but it's one way you can do it. I've got 1x left here, and z to the 5th, and here I've got 8 and x squared. Do I have x squared? X squared. No, this should have been an x to the 3rd. Crazy, crazy. All right, so this is what I should have gotten. But we went over this in class, so you knew I had it right in class. All right, so let's try this. Find the greatest common factor of 21x cubed y and 6x to the 6y to the 3rd. So the greatest common factor of 21 and 6 is 3. X to the 3rd is 3 is my smallest exponent, and for this y, there's my GCF. All right, if I simplify this, Okay, I can find the GCF, divide it out. Okay, so let's try that first. Um, 24 and 32 are both divisible by 8. Let's do this. Okay, and that leaves me with, and I'm going to go ahead and write it big like this. That leaves me with, this would be a -3, and this would be a 4. So -3 and 4 have nothing else that I can factor out. They each have an x in common, so that would leave me with x squared here and no x there. They both have 2 y's in common, so that would leave me with 3 left over here and none left over here. And they each have a z in common, which leaves me with no z's here and 3 z's on the bottom. These cancel out, and I'm left with -3 x squared y to the third over 4z cubed. Notice there's nothing else I can cancel out there. Okay, so that's one way you could have done it, or you could have just said, let me simplify this. 3 minus x is, or 3 minus 1 is 2, 5 minus 2 is 3, and 1 minus 4 is -3, so that one goes on the bottom.